Next up is Lena Hall.
So I'm going to show you how to prototype a distributed snapshot algorithm in F#. So we can use snapshot algorithms for checkpointing system, for future recovery, for deadlock detection, termination detection, ensuring consistency of the system. And there are many approaches on how to perform snapshots. For example, some of them are based on marker messages, some of them use clock. And I'll show you how to actually prototype it in F#. So in general, prototyping is helpful when you need to implement some algorithm in context of existing distributed system, or when you're just trying to understand an unfamiliar distributed algorithm in general. And I've chosen F# for prototyping because it's a great OSS language and it's functional. So it should be intuitive for people who don't know F#. So anyway, the algorithm is called Chandy-Lamport snapshot. And it's based on assumption that there is a cluster of nodes where all of them are available and they can talk to each other and reach each other. Nodes exchange basic messages, which are just usual messages your services are sending to each other. And nodes can also send out marker messages or snapshot messages, which are special types of messages for taking a snapshot. And any node can initiate a snapshot at any moment. So imagine a system where the state is amount of money in a person's bank account, and anyone can send money to each other if there is enough money to send. So accordingly, the state of channels is messages with money in transit between nodes. And marker messages are just for performing the snapshot, so they're not captured as a channel state. So the foundation of everything is a snapshot node type, which is based on abstraction of a networking node, which is just an asynchronous TCP server. And as you see, there are some basic data types like contents, basic message, channel state, neighbor, and so on. Any node can send basic messages to any other node that it has channel to. So here's a send basic message function that takes the content, that basically checks if there is enough money to send, prepares the message, and sends it out to neighbors. Any node can initiate a snapshot, which that means that it persists its local state and sends out a special type of a message, like a marker message, to its neighbors. That means any node can receive a marker message at any point in time if there is a snapshot going on. And when a node receives a marker message for the first time, it persists its local state and the state of the channel it received this marker through. So if it's the first marker that a node receives, this channel state is empty because this algorithm assumes the first in, first out ordering of channels. When the node receives a marker from some other node after it has done a state snapshot, it means that some time has elapsed from the moment it captured its local state until the moment it received another marker. So there is a definite possibility that there are some other basic messages that came through during this time. And these messages, they can't be captured as a part of channel state. They should be captured as a, one second. They should be captured as a part of the channel state because they can be captured as a part of node state of either sender or receiver because they both have already captured their state. And here is basically, if we spool up 3 nodes using the Chandy-Lamport snapshot, let's say they add each other as neighbors and decide to send some money to each other. Like, let's say the first node sends money to the second node and the second to the third node. And we start a snapshot by the first node. And you see that there is a channel state captured and node state captured. There is another thing you can do to make sure that you got your algorithm right. For example, this is a part of TLA plus specifications. If you're trying to enforce some of the distributed system properties like consistency or liveness, so this this is another thing that's very interesting if you have time to look at it. But it's another whole topic. So thank you, and reach out if you have any questions about this.